Okay, hi guys. This is the continuation of our discussion regarding uh, transportation of fluids. Okay, the first part of uh, our discussion is all about pumps, and our discussion will be based from uh, unit operations of chemical engineering by McCabe, Smith, and Harriot. I think lahat kayo meron itong librong ito, no? E-copy. Okay. We have had our first discussion already about the introduction to this chapter as a recap of what we have discussed so far regarding pumps. Of course, the very the very important phenomena that you must have or you have to consider. Okay, you have to consider in choosing a pump is the cavitation. Cavitation is actually a phenomenon that occurs in pumps when gases are present in pump fluids. Okay, it's actually a results in noises and vibrations, and it damages components of the pump such as impellers, which is very important for us to be able to transport fluid. Okay, um, cavitation might and can decrease the efficiency of a pump. Okay, by damaging, sinabi ko, by damaging the impeller or some of the components of the pump. Okay, I have here some of the link, YouTube link for you to watch for additional information. Now, for us to be able to avoid cavitation, we must have a knowledge on a very important variable, okay, in considering a pump, which is the net positive suction head. Okay, the net positive suction head, or the NPSH. It is actually the minimum inlet pressure or head a pump required to avoid cavitation. Okay? It is usually specified in pump's manual or documentation. Okay? Usually given yan pag bumili tayo ng pump during the process of designing a piping system, and you'll put your pump into the piping system. Okay? You have to know the NPSH, okay, of the pump. Okay, or the NPSH required. Okay, basically, ang kukumpitin natin for the system bago tayo maglagay ng pump, okay, is the available NPSH. The available NPSH can be obtained from the existing system. For us, for example, in this particular figure, we have the reservoir, the pump, and then yung destination. Okay? So this particular system in here can give us the available NPSH. Of course, through the calculation or through the use of the Bernoulli's equation or the mechanical energy balance, we can calculate for the NPSH available and then compare it with the NPSH required, which is indicated in the manual or documentation of the pump that you'll be utilizing or using. Okay? Now, the formula for obtaining the NPSH available is this one. Okay? NPSH available is actually equivalent to d sub c over g, if English, multiplied by the suction pressure minus its vapor pressure divided by the density of the fluid minus the friction in the suction line subtracted by the elevation of the pump. Okay, the elevation of the pump. Okay, going back to the figure, okay, C sub A is actually the elevation of the pump. This is the elevation. Okay, this one. Okay. Now, as soon as we have we calculated the NPSH, for us to be able to know if yung ilalagay nating pump is suitable for the system, calculate the NPSH available. You subtract it with NPSH required. Now, if the answer is greater than 0, or it's greater than 0, okay, then it's acceptable. Okay, let us solve this problem. Okay, benzene at 100 degree Fahrenheit is pumped through the system of figure provided for us, which is this one. Okay, so benzene at 100 degree Fahrenheit is pumped through the system. So the system is similar to this one. So we have a reservoir. It's being pumped. Okay, to this height. It's assumed that the surface or the level or the surface of the benzene inside the reservoir is A prime, and the elevation of the pump is A, and the discharge of the pump is B, and the destination is B prime. Therefore, the elevation of the pump, C sub A, is this one, while the elevation of the destination from the surface of the reservoir is C sub B prime. Okay. Now, the benzene is being pumped at the rate of 40 GPM or gallons per minute. The reservoir is with a pressure of 14.7 PSI or pounds per square inch. Okay, while the gauge pressure at the end of the discharge line or PB prime is equivalent to 50 PSI. Now, to make this atmospheric, kasi gauge lang siya, we have to add 14.7 into it. Okay, PSI. Now, the discharge is 10 feet, so your C sub B prime is equivalent to 10 feet, while the pump suction or the elevation of the pump is equivalent to 4 feet. The discharge line okay, is with the diameter of 1 1/2 inch, schedule 40. The friction in the suction line, so we have the friction HFS at the suction is equivalent to 0.5 psi also, pounds per square inch, while the friction losses at the discharge of the pump is equivalent to 5.5 psi. Okay. The mechanical efficiency of the pump is equivalent to 60%. And the density of benzene is equivalent to 54 pounds per cubic feet, with its vapor pressure equivalent to 3.8 psi. Now we're required to calculate for letter A, developed pump, rather developed head of the pump. Letter B, the total power input. And letter C is the pump installed suitable? If the SHR is equivalent to 10 feet. Okay, so this is the question. So, yung bang pump na nilagay is suitable kung yung required the NPSHR or NPSH is equivalent to 10 feet. So first, para makalculate natin lahat ito, ang pinakamahalagang equation is of course yung Bernoulli's equation or the mechanical energy balance. We have delta P over density plus delta B squared all over 2GC. We're using 2GC, it's because lahat ng unit provided for us is in English, plus delta CG over G sub C plus the summation of all the friction losses plus, of course, the shaft work is equivalent to 0. Okay, so for us to be able to calculate for the developed pump or developed head of the pump, which is this one, we have to calculate everything, or rather equate everything to shaft work. So shaft work then is equivalent to negative delta P over density plus, or rather minus, kasi equate niya lahat, so transpose mo sa kabila, magiging negative delta B squared all over 2GC plus, rather, sorry guys, minus delta CG over G sub C minus summation of all the friction losses. Okay, say natin. For delta P over density, we have the friction, or rather the pressure, APB prime minus PA prime over density. This is then equivalent to ang PB prime natin which is this one, 50 plus 14.7. So this will become 50 plus 14.7 kasi gauge yan eh, minus 14.7 divided by the density, which is equivalent to 54. Now, as you can see, this is pound force per square inch. Okay. Converting the inch squared to feet squared, so we will have to multiply it by 144. Okay. Then divide it with 54, so lalabas pound force per square inch, rather feet pound force per pound mass na siya. What about for delta B squared all over 2GC? Okay, this is then equivalent to B sub B prime minus B sub A prime divided by 2D sub C. And as you can see, ito ay galing sa reservoir, so this will become 0. So B sub B prime na lang. Now, how do we calculate for B sub B prime? B sub B prime can be calculated using, of course, the volumetric flow rate, which is equivalent to 40 gallons per minute. And remember, okay, that your Q is equivalent to velocity, okay, times the area. So for us to be able to calculate for the velocity, this is then equivalent to Q over area. What is area? Area is actually the area of the 1 1/2 inch schedule for T. Okay, this is then equivalent to your V is equivalent to 40 divided by 6.34 with the conversion, of course. Okay, this is equivalent to 6.31 feet per second. So this will be 6.31 divided by 2 times 32.2. Okay, that is for delta B squared all over 2GC. How about for delta CG over G sub C? So the elevation, okay, since we're considering the entire system already, this is simply equivalent to 10 because G over GC is equivalent to 1. So this is 10 pound force feet per pound mass already. So meron na kagad nun. And then of course, the summation of all the friction losses is equivalent to 0.5 plus 5.5. Why plus? This is for the suction, this is for the discharge. Suction, discharge. So entire system muna calculate natin. Of course, converting it to feet, pound force per pound mass, so we are gonna have to divide it with 54 pounds per cubic feet, and you multiply it with 144 to convert the inch squared. So this is equivalent to, okay, if we are to sum all of them with the negative sign in it, okay, the shaft torque will then be equivalent to, okay, of course not considering all the yung signs niya, this will become 159.9 feet pound force per pound mass. This is the value of your shaft torque, which is actually equivalent to the change in the head or the developed head of the pump. Okay, that is the developed head of the pump. So we're done with letter A. This is the developed head of the pump. Now, for us to be able to calculate for the letter B, which is the total power input, remember that the work of the pump is equivalent to, the work of the shaft is equivalent to work of the pump multiplied by the efficiency. So if you want to know the work input to the pump, this is equivalent to shaft work, or the delta H, or the developed head, divided by the efficiency. Now, for us to convert this one to horsepower, because we're being asked to calculate for the total power output, usually total power output, or input rather, is reported in horsepower. So it's always reported in horsepower, so we have to convert it. So for us to be able to convert it, we have to calculate first the mass flow rate. Mass flow rate is actually the product of the area times velocity times density. And remember, your velocity times area is your volumetric flow rate. So all we need to do is to multiply this with the density. So this will become 40 GPM, gallons per minute, okay, multiplied by 54 pounds per cubic feet, divided by the conversion factor, which is 7.48 gallons per cubic feet, multiplied by 60 para maging seconds. So lalabas, this will become 4.81 pounds per second already. So we already have the mass flow rate. So for us to be able to obtain the work input, total work input, or rather total power input, this is then equivalent to the shaft work, or rather the total, or the developed head, which is equivalent to 159.9, okay, foot-pound force per pound mass. You multiply this with with the conversion factor, or rather we multiply this with 4.81, kasi di ba remember the unit for 159.9 is foot-pound force per pound mass. So this one is pound mass per second. So mawawala yung pound mass, matitira yung second sa ilalim, divided by the conversion factor, which is 550 for the horsepower, and divided by, of course, the efficiency, which is 60%. This is then equivalent to 2.33 horsepower. This is the horsepower of the pump. Okay, work total power input. Okay, total power input is 2.33 horsepower. Now for the letter C, is the pump suitable? Yung installed na pump is suitable if we're provided with the SHR, which is equivalent to 10 feet. Remember, the equation for the calculation of the NPSHA, or available, is NPSHA is equivalent to G sub C over G multiplied by PA prime minus PB. This is the pressure at the surface of the reservoir minus its vapor pressure divided by the density minus the friction at the suction only minus the elevation of the pump. So we're considering only the pump, suction, and the discharge. This one. Ito lang yung system natin ngayon. Okay, this one. Okay, para malaman natin yung NPSH available. Okay, so let's continue. Remember, G sub C all over G is equivalent to 1. Then, your NPSHA is equivalent to your PA prime is 180 m. So that's 14.7 divided by the density, which is 54. Okay. Minus PB, which is given, which is 3.8. This is the vapor pressure, 3.8 divided by 54 also. Minus HFS. Okay, ang HFS natin is only 0.5. Converting, this one is in PSI, PSI, PSI. So, para ma-convert, divided by 54. Then, you multiply everything with 144 para siya ay maging feet pound force per pound mass, lahat. Okay, itong tatlo. Then, minus, of course, yung C sub B natin, which is equivalent to 4 feet. The elevation. Okay, so this one is not C sub B rather. No? This is C sub A. Okay, elevation of the pump, which is 4 feet already. Yung head. Head yan guys, head. Itong tatlo, kailangan maging head sa head. So, usually ang head is it's either in meters or in feet. So, kailangan in feet. Ilalabas, this will become feet pound force per pound mass. Okay? If you will multiply this with G, or G over GC, everything with G over GC, magiging feet lahat yan. Okay? And you multiply this with 144, lalabas, this will become, the first term will become 39.2 minus 10.1, okay, minus 1.33 feet minus 4 feet. Okay? Then, take the summation for the available NPSHA. The answer will be equivalent to 23.77 feet. Which is very obvious. Why? It's because stated from the problem that your NPSHR required is equivalent to 10 feet. Now, required is just 10 feet. By definition, net positive suction head is the minimum, okay, pressure required para hindi magkaroon ng cavitation. So, kung ang available is less than 10, definitely magkakaroon ng elevation. But, your NPSHA is greater than NPSHR. Therefore, the pump installed is suitable. Okay? Okay, it's suitable. So this is the final answer. Now, after this sample problem, okay, please solve the next two problems. That will be your seat work for the day. You have until 10:30 a.m. this morning to submit the answers of the problem. Okay, so hanggang 10:30 lang. By 10:30, you'll be required to view or watch the YouTube link that I have included in the PowerPoint presentation. Dalawa yun. It's all about, okay, the general types of pumps. Okay, number one, which is the positive displacement pump and the centrifugal pump. Okay? So, then after that, I will provide an assignment. Okay, mamaya ko ibibigay pagdating ng 11 a.m. Okay, after the video presentation. Okay, do you have any questions? If you have any questions regarding the problem, okay, simply send a message dun sa chat room natin or dun sa group chat natin. Okay? Chat lang kayo. That's it. Thank you.